Hey, Dr. Romano, I see you're here again. You getting ready to do another problem?
Yes, a student asked a question on hydroboration, and I'd like to go over it with you. Hydroboration was a reaction using BH3. It was actually a good friend of mine, Herbert C. Brown of Purdue University, who discovered the reaction. And let's go over it. What I'm going to do is add water across a double bond. And we're going to add the water anti-Markovnikov. But the hydrogen and the OH will be coming in from the same face. Let's take a look. This is what you're going to need to know for the DAT exam. I'm going to take a molecule, I'll use 1-butene, and I'm going to treat it with BH3 THF. Whenever you see BH3, think of it as a BH2 and an H. So you're going to think of this as a unit of a BH2 and an H. Now, the carbon that has the most H's, in other words, this has 2 H's, this has 1, that's going to get the BH2. My professor always used to say, think of it as the BH2 is the big bulky area, and that'll go to the outside. So the BH2 will go to the carbon with the most H's, the H would go to the carbon with the least amount of H's. Now, this structure you need to know for the DAT. That is the intermediate. We call that an alkyl borane. And then what we're going to do is we're going to treat it with peroxide and base, and you'll simply replace the BH2 with an OH group, as you can see what I did here. Notice that the OH and the H are in the same direction. No need to know the mechanism. Someone asked me about the little box. They got all scared. You're not going to need to know that, but all I did here was just show how this is formed. Notice I put a dotted line, meaning I'm forming this bond here. The double bond is beginning to break. This bond is breaking. This is making. We don't need to get into the little box, so don't worry about that. Just know the intermediate. Let's try one more. I'm going to take 1-methyl cyclohexene with BH3. Again, put the little H in. The carbon with the most H's gets the BH2, and the other one gets the H. Notice it's in a ring, so I'm going to show some stereochem. These are going in the same direction. Instead of using wedges, I could have used a dash. In other words, I could have done this with it. Make this a BH2, make this the H, like this to get the enantiomer. I'm only going to show one here. Once you get that, you simply treat it with the peroxide base. You'll oxidize it. You'll replace the BH2 with an OH. Notice the final product. You'll have an OH and an H going in the same direction, and therefore you would also get the enantiomer, so you would get a racemic mixture. And that's all there is to it. So for the DAT exam, just remember, you're going to know the reaction, you're going to know the stereochemistry, the H and the OH are going to come on the same face, and know the intermediate, and you're good to go. So as you can see, it's an important reaction. It allows me to go from an alkene into a alcohol. And then once you get the alcohol, there's a bunch of things you can do with it, like oxidation, etc.
Okay, thank you, Dr. Romano. You made that a lot easier for me. I'm going to have to study that a bit. But first, I'm going to take a break. Can I bring you back some donuts?
I'm good. Good luck to you. Bye-bye.
Good day to you, sir. Bye, Dr. Romano.